start the recording. All right, welcome everybody. It's week 3. Today I'm going to have Freedom Drive as we go over the Python skills. We're going to be covering object-oriented programming, decorators, list comprehensions, and closures. As always, if you have any questions, drop them in the chat if you don't want to come off of mute. Otherwise, feel free to ask us questions. That's what we're here for. Go ahead, Reed.
Yeah, thanks, Hunter. So, before I start, whoever has joined, have anyone gone through the lessons that we have on the class? I just wanted to get an understanding, maybe. So we already have like list of lessons that is mentioned here. Um, did anybody gone through it?
Yes.
Okay. So, um, do you have any like doubts or questions that you wanted to bring up? Maybe we can start from there.
When it comes to creating your own, I guess I'm gonna try to pronounce it, but it's de is it tour? Decorator? Like creating your own, yeah, that one. When it's saying about having your own, like how would that be structured? Like I still would like to be a bit more clear on that, like have some type of clarification.
Okay. Yeah, we can probably come to the decorator. Um, so yeah, that's a good understanding. I just wanted to get an understanding. All right. So let me just quickly cover the basics first. Maybe we can jump into the decorator and get into more details. So the class is kind of a blueprint and template, right? If you look at these key terms that is listed. So first thing is the class is a structure. And when we talk about class, whatever we learned so far, for example, the list, or it could be strings, or um, the set, for example. So everything is class in Python. And even for enterprise application, when we deal with a bigger design to solve a bigger problem, the we usually break it down into multiple class, and then we deal with the objects. So the major difference we need to keep in mind between class and object is class is providing you the structure, how the object will look like, where in the other hand, the object or instance is nothing but a kind of um, you know, one piece of the class, one object of the class. Okay, one instance of the class. So as it says, right, the actual cookie made from the cutter. So when we look at an example, maybe I can take the example that we have already. For example, dog. Dog is a class and it has few properties. It could have a name and age. And I'll come to this class property later, class variable later, but mostly we should have some property of a particular class. So this structure basically provides you the overall what it can do or what it consists. Whereas when we are creating the objects, this object is referring to each object is referring to a structure of class. So when we say dog1 equal to defining a object, it's basically having all the property that we have part of the dog class. Okay, so that's basically we're trying to say the difference between how the template looks like versus when we create the object, it contains the property and method and all the necessary things that is included in the class inside your particular object. Okay, so if I look into more details, So as I said, like class is a blueprint, and whereas object is a specific thing created from the class, specific object, or one particular, defining one particular person, for example, from a human class, right? And then there are a few things we need to keep in mind, like self or init, or it could be, many other classes that is already inbuilt. And then we have something called method and then attribute. So start with self. Self is nothing but it's reference to the current object. So that means when you define a object, for example, dog1 is one of the object, and when you are trying to uh, assign some, let's say, name and the age, it's passing this name age part of init, and this init is a kind of inbuilt function, you can say, part of a basic class structure, which helps you to define the properties that we have. And this self will make sure the object that you are trying to assign, it is referring to the current object. So for example, we have dog1, dog2. These two objects are referring to a different set of list of property, because this is different objects. All right. And am I making sense? Just, throw questions if you have any doubt in between. And then the self, or in some cases, if you consider C, C++ or C Sharp, we call it this. Even in Java, we consider it as a this. So for Python, it's called self. Self is nothing but referring to the current object. Okay. And init is a constructor. So what is constructor? When we define an object, this is the first thing it gets called. So we may have, let's say, different methods or functions in our class, but when we are trying to create an object, it's the first thing it does is it's automatically calls the init. All right. So that's part of a property, default property, when we are creating a new object. And then we have something called method. Method is something similar to function. We already know how to write a function. And this method is part of the um, class template, where you are trying to define your own function. Right? So for example, call or speak, these two are method, which can only get called part of your object that you are deriving from your class. All right. And then something called attribute, the property or the attribute that I was talking about, right? We have different property like name, age. These are all called attributes, because when we are creating the template of a class, we also have a particular property or attributes to that particular structure, and these things are basically called the attributes. Okay, and then let's get into the class variable. So this example is like, let's say we wanted to get the count of number of objects that we were creating for this particular class. And one option is to define a class level variable. So this count is like class level variable, and a typical way we define as a underscore and then the name of the variable. That makes sense. I mean, that will tell you this is part of the class variable. Okay. And then now the question is, what is the use of this class variable? How we can utilize it, right? So if you see, what it's trying to do for in this particular example, we are trying to create a count variable which we wanted to use to get the number of objects created, for example. So what's it's doing, it's trying to increase the count, initiated to 0, and then part of init. And as I said, like init will be called in each creation of the object. It's trying to um, add up on top of what is the default value set. And how are we going to do it? Since it's a class variable, we have to call like class name dot the variable name. This is how we can access within the class. Okay, so yeah, this is about it. I'll come to this class method later when we'll talk about decorator. But I just wanted to quickly cover the inheritance part as well. So we learned what is basic class, which is a kind of like structure of one particular object. And then we have something called inherit. So inherit means, let's say we wanted to utilize the same structure that we already have, and then you wanted to build something on top of it, right? So one example is like we already have a dog object which has a specific attributes with some methods we already have, and then for a species of dog, for example, we wanted to add something more on top of the basic basic structure that we have. So one option
Freedom,
is, yep, go ahead.
can you zoom in a little bit for the laptop viewers, please?
Yeah, sure.
Thank you.
How do I zoom in?
Control plus if you're on Windows.
And Mac. Okay, it
Yep.
works.
Yep. There you go.
All right. So when we talk about the inheritance, since we already have a property of I mean, we already have a structure of a class, we don't want to rewrite all these, essential functions or method that we need in our, let's say, inherited in a different, let's say, species of dog. So what these inherits do, it will inherit all the property that we already have in that inherited class, in the base class. This is also called base class. It will inherit everything that we have here, and then you can um, write your additional features that we have in your particular species of the dog that we are wanted to create a new class. So the way it does is class name, and then within bracket we need to mention the base class. And this is the structure is kind of similar, right? We have again init function where we are trying to set the super.init, which will make sure to call the base class init function. So again, what will happen when we create a big dog, it's going to set the name and age, but the attribute is going to call the base class init, and it's going to set up the name and age. So that's the purpose of like super dot init. It's going to call the base class init function. And the way it's called, it's kind of same. This is again part of the same concept where we are trying to create a new object. The init functions comes into picture. Okay, and then these are the additional feature that I was talking about. We already have, let's say, call or speak from the inherited class, and then on top of it, we wanted to add fetch or maybe speak verbose. And this speak, if you notice, this is already there in our base class. Whatever we inherited, this is already have it, right? Now, what if we um, define another speak here, which is called override, and call big dog dot speak? What do you think which function it's going to call? Because we have the speak function is available in both, right? So here, for example, we have declared one object, and this line I'm talking about doc3.speak. So what do we think? Which print will come up? Is it going to show you woof woof woof, or it's going to give you bark 3 times?
Hermain says wolf. Apiri says wolf.
I'm sorry, what is that?
They're saying woof, woof, woof.
Okay, let's try this out. Let me run the first function. Okay. So it's going to say bark, 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 and then woof, woof, woof. Sorry, woof, 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 then bark, bark, bark. Sorry. I mean, this is same thing written over here, super.speak. That's the reason it's coming up again and again. But if we comment this line, maybe it would be better to visualize how it works. So you see, this is calling woof because we try to override what we already have in our base class or in our derived class, right? So that means when we create another function with the same function name or same method name, it's going to override the base one. Okay, so that's called override of function. It's very important piece of like class definition, because when we will deal with existing Python class to build up our own additional features, or maybe we need to modify um, in our own way. That's why this overrides comes into picture. Right, coming back. Any
So
questions so far?
Jenny has a question. And by the way, Jenny, I believe you are correct. So she wanted a little more clarification on super. So super is used to call the base class, which is dog. If we could just go over that a little bit with her real quick.
Yeah, so this super, as Hunter said, like this is going to call your base class, right? So when we are instantiating a base class in your, let's say, new class, if we wanted to set up in a different way, I mean, again, this is coming part of overrides. If you want to override, then we need to provide how you're going to override. But if we don't want to override specifically for init, we need to say that, okay, when we are creating a new object of big dog, it should initialize the the attributes, whatever we have in the base class. So that's where super come into picture. And then same thing for here, if you see in the speak variables, we call super.speak. Oops. Super.speaks. What is going to do, it's again going to call the base class speak function or speak method. Okay.
Next, they're talking about, they're asking about priority. So Lily and, sorry, I'm going to butcher your name, Svatoslav, is asking about how super overrides the attribute. So we're talking about priority here, like which one calls over which one. So super.speak overrides speak.
Yeah.
Right? If you want to expand on priority a little bit with them.
Yeah, you were right, Hunter. So this super basically overrides the this pick. So when we say super.speak, we are specifying the method, this pick verbose method, to call the base function or base method instead of picking up this one. But when we say self.speak, what it's going to do, it's going to refer to the current class. I mean, the object is going to refer to the current instance. So if you see these two lines where you are trying to force trying to force this method to call the base class first, and this is not gonna take the woof, and then finally you are trying to say, okay, next time I don't want to call the superclass or the base class, rather than I wanted to print the override that we have. That's where the self come into picture, because self is pointing to the current instance of your class.
Okay, and then the next questions are going to be Jenny wants to know if speak verbose would override speak. And since those are two different variables, I thought maybe we could point that out as to why those work for her. And then we'll go on to the next question.
I'm sorry, the speak verbose overrides, I missed that.
Yeah, Jenny wants to understand. She said, to clarify, she thinks that you were saying speak verbose, override speak. And since speak verbose is actually a different variable, I thought you could point out how that is different from speak to her.
Okay, so speak verbose is another method,
Mm.
right? And inside speaks verbose, we can, the way it's written here, suppose we wanted to decide which speak we wanted to call. So that's where the difference comes into picture. Like this is a method. It's not a variable, right? And this method we can choose how the verbose would look like, whether we wanted to deal with the superclass or the current class. Is that clarifies? You can
So,
unmute and talk if you want.
did that help you, Jenny? A bit confusing, but she will read on it later. Okay. Basically, like he's saying, it's this method is calling speak, but it's modifying it. So when you call speak verbose, everything inside that method is what speak verbose is going to call. That's what's inside its scope. So when you start looking at scope, then you'll see the method inside the function only has the local scope right there. So when you call speak verbose, it's going to do super.speak, self.speak, because those are inside of its scope.
Right. So the self speak is local scope again, and this is the base class scope. That's the purpose of like showing you this example.
Jen says, thank you.
Right.
The next question is, can we build another class over super to make it a 3-layer, like hyper, super, speak?
Yes, we can. So once you have, let's say, big dog, I wanted to build another class called big dog, maybe, something bigger than this. So then we can do the same thing, like what we have done here. For example, oops, I'm sorry. One second, this is too big to deal with. All right, so let's say I wanted to define another class here called big dot here in part of here. So if I understand the questions, you wanted to know if we can do like bigger, let's say, 3 times big dog, which will inherit the big dog, right? Because this is all, I mean, it's a multi-layer inheritance, you can call it. And this should work because what it's trying to do, it's trying to, the concept is same, right? The the bigger one, I mean, let's say for our case, big dog, which is referring to the another class, which is again inherited with the base class. That is the basic information with the attributes and method we have. And inside your final class, it will be multi-layer inherited. So that means this final class should have everything that you have from dog to big dog, and in addition to that, your new functions. So let's say we wanted to, something, I don't know, maybe speak, bake, something like that. So it can have its own local method, or this will work as a part of this current class, and then this could also have speak verbose, and it could also have fetch, and you can also instantiate the base class speak call dog, and also initiate with the attributes that you have in your base class. Okay.
Said thank you very much.
Mm-hmm. No problem. So let me quickly look into. So this is an example where I just try to explain how we can utilize the um, existing method, how we can override. So str is something we already know. This is a string conversion class where we wanted to convert something into string, maybe an integer into a string. So this is a Python class. Okay. And I think what we can do to explore more, if you just type in docs.python.org, you should have the documentation. And if you search whatever existing Python class, for example, str, I think we should have it somewhere. Okay, here. So you can find the class. These are all the built-in class inside Python. And from docs, you can explore how this function are written, what are the methods, and you can also find out these are the methods, for example, that you can override, right? We learned how to do override here. This is how we do usually overrides. So let's say, for example, you wanted to do a specific operation for your str conversion type, and you wanted to utilize the existing base class that we already have, and maybe you wanted to override the case fold, for example, or maybe center. These are all the existing method inbuilt in Python. You can instantiate through inheritance, and then you can override the methods that it's already have. Okay. So yeah, this is mostly it. Maybe we can jump into the decorator now, right? Any other question on the basic class structure? What is object? How to build methods and anything? All right. So now let's talk about, yeah, go ahead.
A man wants to know if you want to edit the parent class. So I think what he's asking is the parent class immutable?
Immutable, yes. I mean, we can modify the parent class anytime we want. But one thing to keep in mind, once you have something change in the parent class, that's gonna reflect in all inherited class, because this inherited class is holding the same property of your base class.
Yeah, so to follow up on that, basically your parent class is your core of what everything is going to share all across the board. So you can have you have your dog and you can have dozens of kinds of dogs. You can have a small dog, a big dog, a poodle. They will all share the same dog thing, a name, an age, legs, you know, bark. But then if you want to add things that aren't common to the class, that's where you would use the children. So if you wanted a flying dog or a Rottweiler that had something different. And so yes, it is better to create an inheritance class with the modifications that you want rather than to change the parent class. Think of the parent class as like your cookie cutter, and then afterwards you can change the recipe. Kamang says, if there is a mistake in the parent class, we will have to change the code itself, or can we recall the parent class and change it later?
So, for example, the call dog, you wanted to change in your big class, big dog class, for example. And maybe you are thinking maybe you did some mistakes here. The one option would be create another override in your um in your child class, and then you can modify the child class in your own way. But one thing to keep in mind, this is since it's a base, and if there is any issue here, we should always try to treat that first, because this may impact in future when you are going to instantiate for other classes. That makes sense?
And yes, thank you.
Okay. So moving forward, let's talk about a little bit about decorators, right? We can first look into some um, key terms that we need to know. So decorator is a function that wraps another function to add extra behavior, right? And it's can be defined with the @ the decorator name. Okay. So if I get into the details, these are the few things we need to know. First thing is the syntax, how we use. So decorator is, as we said, it's another function, wrapper function that we need to define as @ with decorator name. And then wrapper is nothing but the inner function that we wanted to call from the original one. I can get into more details how the wrapper works. And then this is similar as the function argument that we already know, like, how to pass multiple arguments to catch all into your function. And this one, I believe it's okay. So this is something when we wanted to preserve the original function name, right, in the doc string. That would also help. So let me get into one example. So first thing I wanted to talk about this basic class again, where if you see there is something called class method. So this class method is a one example of a decorator, which is defined part of default Python library. And what it does when you decorate one of your method with @ class method, it treats this method as a part of a class. It's not a simple method that you have like call, doc, or speak. And what additional thing it's going to do is it will wrap up um, into additional function. And when I say additional function, that's part of the class method. If you see this, the pop-up that came up, it has another F function, and then there are parameters like CLS, and then argument 1, 2. So this is the additional function that I am talking about that will get called automatically when you define your method as a class method decorator. Okay, so I'll probably break it down a little more. So if you see there is one call we have with dog class, and when we specifically talking about class method, we need to call from the class name dot the method name, and this method name will invoke the class and find the variable of the class. So that means internally it's doing something more. It's just not returning the variable count, but it's also um, it's also making sure the CLS, the parameter that we pass, it's a class type. Okay, so that's where if you see the simple method call goes like object dot method name, whereas when we are talking about class method, it's a decorator. So we are passing dog dot method name. Okay, and then this is similar example I can show you here. This is a circle class, and circle has, let's say, many property like area, diameter. And if you uh, see, there is a one decorator added called property. Now, if you think about, let's say, we don't have this property here, the way we should find the area is simply we can create the object and then we call the method c dot area, and this will give you the area. But when we are defining it as a property, what it's going to happen, this area, it's considering as a property of particular class. And again, this is a existing like the part of the Python decorator. We need to know like how it reacts, what is the purpose of these decorators. So that's where we for property we know this is how we need to call the property, and that's where this decorator comes into picture, right? And let me run it. So you see, this is giving the same thing, but it's treating the area not as a method now. It is treating as a property. Okay, so when I say property, let's say uh, we can um, we can have a, let's say, circle has multiple things like uh, maybe it can also have a class variable, for example. So we use dot operator to access those class variable. So we wanted to make similar kind of feel for our area and diameter as well. That's why the property decorator, it's calling additional function inside, and then it's inside class, and then it's making sure the value returns as a property, not as a method class. Right? Hunter, you want to add anything?
So think of decorators like gift wrapping. All right. So say the circle was like one of those cascarones eggs. I don't know if everybody knows what that is, but it's the egg that is filled with glitter. And you have the gift. It's your function. So the decorator is like wrapping paper that goes around the gift. You can add a bow or a tag, which is the extra behavior. But the gift inside the cascarone egg will stay the same. So the at logging wrapping, if you wanted to do that, would be like adding a note saying gift was opened at 3 p.m. You could add a wrapper like a timer that adds a stopwatch to see how long opening it took. You could also add one like require login that adds a log that checks if you're allowed to open it. So the decorators are ways that you could take the original function and give it more things, extra behaviors, so that you can see, different things that you need to do. Like I was talking on Wednesday, like the logging is very important. Like say you have an input box and you want to know who's logging in with your input box. So with the logging wrapped around your input function, every time it logs a username, you could get it to drop into a file with a timestamp and who logged in, and etc. So these are things that you keep in mind, or like they're little extra behaviors that you add to the original base function. Coming back to read them.
Yeah. So yeah, thanks. So maybe we can get into a another example. Not the built-in one. Maybe we can look at a custom one that will probably help to. I can quickly get into here. Maybe we can have it something here. So you see, this is a custom decorator, right? So as Hunter was saying, like there is a wrapper inside it that we wanted to call when we will call our decorator. And how it's going to decide is it says a decorator is the @ sign will define as a @ with the decorator name. And when we are doing, let's say, a print name, and we're passing some name inside, this decorator is taking the entire function. So as a parameter, you see, this is taking a function. And what is function gonna do? It will call the wrapper, right? So this is one type of, what do I say, encapsulation, you can say. Okay. So finally, this print name is going to call the print function and print out the name of the person. And if you see, the wrapper also have wrapped around print hello and then print world. So your function call is giving John, for example, and then it will also get wrapped around two more print statement or whatever line of code you have. It will be wrapped around and return the entire thing when you call the decorator function, when you are defining a function as a decorator. Right? So finally it will give you like hello John world. Okay. And if you see, it's returning the entire wrapper. And in this case, wrapper is nothing but a function, which function is returning from the decorator, and this decorator is defined here. Okay. I know it could be a little confusing initially, so maybe you can try a few examples and then you can get used to it more on this. Right. So yeah, that's all I think for now. Maybe we can again have these the work the practice code, and then you can come back, and if you have any questions, maybe we can look into all details. So what we have in next is list comprehension. Hunter, do you want to take up this list?
Sure, I'll jump in here.
Mhm.
Let me take over the screen.
Okay.
All right, so, and again, drop into the chat if you have any questions, or come off mute while we go over this, because this is a little difficult to wrap your head around the first time. So list comprehensions are Python's way to create new lists, dictionaries, or sets by transforming the existing data. So they're going to replace multi-line loops with a single readable expression. And when you're doing large code bases, if you can condense your code, it's going to make it a lot easier to go back and see where you might have an error rather than having to go through all the nesting that we just showed you. So list comprehensions is one of the ways that you can kind of clean up the verboseness of your code. So we're going to go over some comprehension anatomy. So the basic syntax is the expression for the item in the iterable. The with filter is the expression for item in iterable if condition. And we'll get to that in a second. A dictionary is the key value for the item in the iterable set as the expression for the item in the iterable. And the generator as expression for item in iterable. Right, so we're going to start with, let's just start with a very simple loop, right? So we have the loop nums. In the loop nums, we have 0 through 4. And then we have an empty one, squares, right? So this empty list and nums are our first two counters. So for our for loop, we're going to iterate directly over the elements. So for every n in nums, right? So this is going to be n right here. N, 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 right? And as you iterate through every n in nums, we're going to do square append n times n. Okay. No problem, Tiffany. Finish my homework. And again, reach out if you have any questions, either me or read them, all right? All right, so as you see, the output is going to be 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4, so on and so forth. Because where we appended in here is the ends that we iterated from the original nums. And then we take that and we're appending it into the squares list. Makes sense to everybody? All right, so that's one way to get it to work. I'm going to show you a little bit better way to do this. We're going to do the same thing, but this time we're going to take our nums and we're going to do a list comprehension. We're going to do squares equals n times n for n in nums. Then we're going to print the squares. As you can see, we're getting the exact same output, but it's just one line of code. So you're doing everything that we did right here in this for loop is just being condensed already in here in the list comprehension. Everybody follow that? All right. Now, we're going to make it look really cool. So this is the best practice. We're going to do comprehension with filtering. I don't expect you guys to understand all of this right now, but I just want you to see what you're going to get to eventually. So this is going to transform and filter in one expression. It's going to be highly readable when you know the pattern. So nums, we're going to give it the range of 10, right? So it's going to square. Then we're going to set this up so that we square only the odd numbers. So as you read this, you'll read out n squared for each n in nums if n modular by 2 has a remainder, which means it would be odd. Because if it was 0, we'd know we were dealing with an even number. So this would give you all the odds in your squares. So when you print odd squares,
odd square.
what was that? I didn't quite hear you, Benita.
Oh, sorry. I thought I was muted.
Oh, no, it's all right. I just thought maybe you had a question. All right, so same thing with the names, longer than 2 characters, uppercase. So say you want to go through a list of names. We have the long names equals name dot upper, because upper is going to uppercase them, or name, which is going to be each one of these. in names if length of name greater than 2. Okay, so then you see we got Ada, Bob, Grace, but not Al. And it put them all to upper. You could also do 2 lower. That's another method that will make them all lowercase. Why would you want to do something like this? So, data validation. You're going to get to that later, but when you have an input box and the users can put in data, one of the things you really want to do is control what they put in there. So, do you want to have to take into account every possible iteration of how they might spell Ada? Like perhaps they had a twitch or a sneeze and they do lowercase a, capital case D, lowercase a. That's not something you really want to spend time accounting for. So you could take everything that's brought in, switch them all to one equal format. And then that makes your data easier to work with. All right, so, and again, you can do the same thing with dictionaries. Let's see if I got any other examples here. No? All right, so let's switch over to here. Is there anything you wanted to add to that, Rita?
No, I mean, I think it's good. Just wanted to just wanted to like highlight that don't get overwhelmed with all these intermediate or advanced stuffs, because sometimes it's tricky to come up with the comprehension. So maybe we should start looking at the basics, like how we can build the loop, and maybe then one step ahead at a time, rather than just trying to digest everything together. So I mean, just talking about whoever is new to it. So that's probably would help to go step by step.
Run it back. All right, so the for loop. We're going to iterate directly over the elements. So when you're iterating, it's just like how you would do like as a person. Like if you had a list on a piece of note paper, you would iterate through it one after another until you got to the end of the list. This is the same thing that the computer is doing. It is just a fancy word for that. It's iterating the 0, it's iterating the 1, iterating the 2, on and on until it gets to the end. So then what do we do with those numbers after we've worked with them? We don't want to mess with this because this is the original list. So that we've created a new one, an empty list to put our data into. This is also the same kind of thing you do with a set. Like a set will take all the unique items from this list. So say this one was multiples of some of these numbers, and you wanted to know if you had all the numbers between 1 through 10. You could iterate through this list with the set, and it would put one of each of the numbers that are found into this list. And then you would have your set of unique numbers. And by doing that, you do that with the for loop. So the for loop is going to continue by running through ones. If you need to go through it again, and that's when you're going to start adding more features to it, like a nest or something. Let's see. So, let me make sure we're not getting too deep with this. All right, so with a dictionary comprehension, you have the key value for item and iterable. So let's start with a simple one. You have the names that we were looking at earlier, Ada, Bob, and Grace. We want to create a dictionary mapping each name to its length. We have the names length, which is the variable we're going to store everything in. And in here, this is where we're going to do the list comprehension. So we have our name, the length of the name, and for name in name. So you can see that it's going to sort this when we print this out. It's going to give you the key value pairs. The name, Ada, with the length. Bob with the length. Grace with the length. Makes sense to everyone? So, like Rita was pointing out, the loop, the for loop right here, it's the same as the multi-line loop up here. It's just condensed into the list comprehension inside of the brackets. So you're doing the exact same thing that you've been doing before with your for loops that you've practiced before. You're just putting them onto one line. Because the spaces are for the human beings. That's so that we can read it better. The computer doesn't care. Right? This could all just be one minimized file. I don't know if anybody's ever looked at a minimized file, but it has all the spaces and everything taken out of it because the computer doesn't need it. It just takes the block of code, reads through it. We need to be able to read it. So that's why we break it down piece by piece. So now we're back to the sets like I was talking about. So again, the expression for item and iterable. So we have the words, 4 words here. We want to get the unique word lengths. So this is where it's only going to bring out one of each unique one. Because Ada and Bob are both 3. So when it iterates, it's going to see 3, it's going to see 3, and it's going to drop 1 because it already has 1. Then it has Grace and Turing because those are 5 and 6. So you see that in here by the length, the W for words. So for W in words and iterates through each one. Now, since we're doing the set, 3, 5, 6, because we had 2 3s. Everybody following along with that? Okay. So you can see the square brackets are the list. The curly braces will give you the dictionary of the set. And then there's the generator, which we'll get to the generators in a minute. Is there anything you want to add to that one, Reedham?
Yeah, so as Hunter is saying, like this will probably help you to manage the code better with smaller lines of code. When we get into a bigger project, there will be millions of lines of code, and definitely you will try to leverage this list comprehension to minimize the line of numbers of your, entire project. That will be helpful. And once you get used to it, this will be more easy to write, less line of code as well as less number of what do you call words and overall less thing to do. That's always it's gonna help a lot.
All right, so we're coming up on time here, but if anybody has any questions right now, I would take the last couple of minutes to address those. Feel free to come off of mute. All right, thank you, May. All right, Louis. Thank you. Have a good night. I'll enjoy your weekend. You're welcome. Okay. Recording.